All right, last half of the lesson. Distance from a line. All right, the distance from a point to a line is the length of the perpendicular segment from the point to the line. Oh goodness, I did it again. Sorry. Line. Point. We've learned that the shortest distance from a point to a line is a line perpendicular from that point to that line. Okay, so the distance from a point to a line is the length of that segment. Okay, the length of the segment, we'll call it little d distance. This perpendicular segment is the shortest distance between the point and the line. I'm going to give you a little refresher. Distance equals x2 minus x1 squared plus y2 minus y1 squared. You need this, okay? Write it down. Also, what we should say, what I need to remind you is if I have parallel lines, and I know they're parallel because I've got handy little arrows. Okay, the distance between two parallel lines. Actually, I think I have another slide on this, so let's save this for the next slide. But what we've said here is enough for this slide. There's another one. Yep, I did. So the distance from a line, the distance between two parallel lines. I have two lines that are parallel. If I could only move the ones from the previous slide over. Two lines that are parallel. The distance between two parallel lines is the length of any perpendicular segment joining the two lines. So I've drawn a segment in between the parallel lines that is perpendicular. And the distance between the 2 points, the length of this segment is the shortest distance between the two parallel lines. So we're going to be using that opposite reciprocal slope and finding some points and actually calculating this distance. All right, so the sculpture shown on the right is drawn on a graph where units are measured in inches. What is the approximate length of SR? SR is right here. What is the approximate length of SR, the depth of a seat? So we need to find a quick slope of these points. Okay, guys, you may think this is a word problem you're not going to see again, but you need to use the skills in this word problem for non-word problems in your classwork. So don't zone out. Work with me here. Okay. I have legs of this chair. There's a leg. Okay. There's a leg. Those legs are are parallel. To find the approximate length of the depth of the seat, that's the perpendicular piece. Okay. So I want to make sure these are perpendicular. So let me write down all these points. I have S is 35 and 120. R is 50 and 110. And P is 30 and 80. All right, I'm going to do, what is the slope of the leg? I'm going to make sure everything's parallel. The slope of each leg, if I did P and R, my slope is going to be change in Y. So I want the slope of this leg. $110, change in Y, over change in X. 110 minus 80 is 30. 50 minus 30 is 20. My slope is 3/2. Okay, let's look at SR. The slope of SR. 120 minus 110 over 35 minus 50. So I have 10 over negative 15, which simplifies to negative 2/3. Thank goodness they are perpendicular. Opposite reciprocal, they're perpendicular. Okay, I need another page to work on, so let's fast forward. Okay, let's put our points down. I have S, which is 35 and 120, and R, which is 50 and 110. Okay, we need to find the distance between these 2 points. If you remember, distance equals the square root of x2 minus x1 squared plus, that's awful, y2 minus y1 squared. x1, y1, x2, y2. 50 minus 35 squared plus 110 minus 120 squared. 15 squared, negative 10 squared. 15 squared is 225. Negative 10 squared is 100. Square root of 325, 18.0 inches. Don't forget your units. All right, not so bad, right? All right, this is a you try, but we're going to do this together since the example that we just went through was a word problem. I want to make sure you understand it, so we're going to work through this one together. Use the graph at the right for exercises 5 and 6. We're going to do number 5 right now, so don't worry about number 6. What is the distance from point A to line C? Okay, we have a line. The distance from point A to line C, it's going to be a segment that's perpendicular to line C. So I have a segment here, and it has to be perpendicular to line C. But I'm going to erase that for now. So if you look back in your book, it says that the distance from a point to a line is the length of the perpendicular segment from the point to the line. So let's do the slope. What is the slope of line C? I'm just going to count it. I'm going to go from here to here. So I go rise of 2, run of 1. The perpendicular slope is then going to be negative 2. No, sorry. Goodness. Negative 1/2. Opposite reciprocal. So let's look at this. I'm going to go down 1, positive 2. Down 1, positive 2. And this will be my line perpendicular. Now, reading this is a bit of a challenge, but we're going to say the coordinates for A are simple. I have negative 3, 2. And the coordinates for the intersection, we're going to call that, I don't know, P. It looks to be negative 0.5, positive 1. And we would have to do the distance formula for that. So I'm going to write the distance formula out, but you guys can calculate it on your own. Negative x minus x plus y minus y, that squared and that squared. I'm going to push pause and get the answer to this, but please calculate it on your own and make sure that you can get the right answer too. Okay, I got about 2.7. Okay? Now the distance from line C to line D. C and D are parallel, even though it does not state that. But we've learned today that the distance between two parallel lines is the length of any perpendicular segment joining the two lines. So we already know that this line that I drew in black is perpendicular to C. Therefore, we've learned a theorem that says it's also perpendicular to D. So we really need the distance of this segment. Okay, we have that one point right there, which we already labeled P as negative 0.51, and this point right here, it looks to be about that point. We're just going to name that 0.10. Okay, you guys find the distance between these 2 points, and then we'll check your answer, okay? I have the distance for this one is equal to about 1.8. Don't show me your notes tomorrow with the answer and expect to get full credit, okay? I want to see your work, calculating the distance using the distance formula. Okay, another you try. Graph the line. What point on the line is the shortest distance from the point 4, 1? What is the distance? Round to the nearest tenth. You guys try this one on your own, okay? Push pause and try it. Okay, I labeled part A, or question A, what point on the line is the shortest distance from point 4, 1? First of all, I figured out the slope of the existing line, which I wrote right here. Okay, just found the slope of that line. Then I plotted point 4, 1. And found the perpendicular slope, which is negative 1. Negative 1, positive 1, negative 1, positive 1. There is the point that is the shortest distance right there. So I'm going to turn the page, and we're going to figure out the slope of, the distance between these 2 points. So I'm finding the distance between point 2, 3 and point 4, 1. Push pause and finish it on your own. So the distance is 2.8. Okay, here's your daily homework quiz. Push pause, write them down, turn them into the inbox in the morning and get your credits. Extra credit if you would like it. Last question, okay? Go ahead and try it.